All right, let us now read question B. And I think I'll answer all of these question B questions in one video here. So it says, the equation of the least squared line predicts that sometime in the future, the women's winning time in the 12-kilometer run will be lower than the men's winning time in the 12-kilometer run. So sometime in the future, the winning time of the women will be lower than the winning time of the men. Let's just take a step back for a moment and really appreciate what's going on and what this is telling us. What is this graph telling us? So it's telling us the difference in minutes between the men and women's winning time. So initially, the men are faster than the women. So the difference is quite large. But over time, the difference is decreasing, okay? And soon, we're going to get to a point in which the difference is zero, right? Meaning the men and women are finishing this race at the same time. But then, after that point, as this question is saying, we're going to get to a point where the women are actually running faster than the men, meaning they have a lower winning time. So what we want to figure out is in which year is this first predicted to occur? So in which year is it expected to occur that the women will have a lower winning time than the men? So the way that you should approach this is you should say, well, let's figure out when there is going to be no difference. So in other words, when there's going to be a zero difference between the men's winning time and the women's winning time. So I'm going to go menu 3-1 to solve. And I'm going to say, I want a difference of 0. Now I'm going to cheat a little bit. I'm going to come up here. I'm going to get rid of that 2021. I'm going to put X in there. Oops, I'm on caps for some reason. I'm going to put X in there. Then I'm going to go equals to 0. Oh, where's 0? And then I'm going to solve it for X. Oh, am I locked on? Sorry, I'm locked on capitals. There we go. That's better. So as you can see, what I've done is I've taken my least squared regression line here. I've set it equal to 0. And I'm solving it for X. So that's telling me that in the year 2035, I am going to get, there's going to be no difference between the men's and women's winning time. Now, I want to get to a position in which the women are running faster, meaning it's not going to be 2035, it's going to be one more. And you can actually see this in action. Like for instance, whenever you're unsure about rounding up or rounding down, just sub it in. So for instance, what happens in 2035? Well, as you can see, I'm still getting a positive value out, meaning the men are still running it faster. But now if I put in 6 here, now I'm getting a negative value out, meaning the women are now running it faster. So my answer here will be, let me quickly grab this, 2036. And if we look at our thing, that is it, 2036. All right, now we go to the next one. It says, by how many seconds will the predicted women's winning time be lower than the men's predicted winning time in this year? Round your answer to the nearest second. All right, so what we're going to do here is we're going to take this 2036 and we're going to plug it into our equation, which we've already done. And we've gotten this answer out here. Now, you're looking at this and you're like, what on earth is this? Negative 0.10872. This is where you have to be careful. Because remember, this here is giving us difference in minutes, okay? It's difference in minutes. So this right here is the difference in minutes. When what we want is we want the difference in seconds. So what you're going to have to do, I'm going to come up here, I'm going to bring that down, and I'm going to times it by 60, and that is going to give me this. Now I need to round it to the nearest second. So my nearest second is going to be 7. So 7 seconds. So that means by how many seconds will the predicted women's winning time be lower than the men's? It's going to be 7 seconds. So you just need to make sure you times it by 60 in order to get that answer there. And sure enough, if we come here, the correct answer is 7 seconds. All right, the next one is the equation of the least squared line was, the equation of this least squares line was calculated using data for the period of 2008 to 2018. What assumption regarding this least squared line is made when the line is used to make predictions for years after 2018? So it kind of, it doesn't want you to say extrapolation, all right, but that is what's happening here. We're extrapolating here, but it wants you to kind of describe the assumption that's going on. So let's look at our examiner's report and we'll just write exactly what they've told us. So it says a similar decreasing trend continues beyond 2018. So in other words, the trend that we're seeing continues on. When we're extrapolating, that is what we're assuming. So it really just wants you to spell out what extrapolation is assuming. And it's assuming that, the trend is going to increase beyond 2018. And that is it. We've come to the end of this section. There's more to come.